Good evening. So I'm here to talk to you about AI as a tool for energy efficiency. I kind of debated when I was choosing the topic for this talk, but I went with this because that will be the main focus of today's session. A quick introduction. As you saw in the opening slide, I currently represent a company called Syntax Genie. I'm the CEO. We have a few of our team members here in the audience. The lights are so strong, I cannot see who's in the audience, but they are there. I also work as a faculty member at the Department of Electronics and Telecom Engineering at the University of Moratuwa. So today, I wanted to touch upon a few things, and the main focus of that being a case study. So I'll take a case study based on a product that is relevant to machine learning, and then that case study, as you can see, is sandwiched between a brief history of innovation, and then we'll conclude with a call to action. So that's what you can expect in the next 30 minutes or so. So let's start. A brief history of innovation. I wanted to set the context, and then when we conclude the session for today, mainly the call to action will address you. That will be the call to action for you guys. When you look at a brief history of innovation, over the last 5 decades, we can see 5 main cycles of tech innovations: computing, internet, cloud, and mobile. Each one of these tech innovations was powered or triggered by a certain incident. If you take the internet, for example, that was our trigger, and that gave rise to a mass market innovation, for example, Amazon. So you can look at each of these technology cycles that caused a paradigm shift, and then identify these triggers and the mass market innovations that came out of it. But the road from the point of the trigger to the mass market innovation was not linear, of course. It took somewhere between 3 to 6 years, but the trend follows what we call the Gartner's hype cycle. It's called the Gartner hype cycle because that was presented by a research organization called Gartner. They said that whenever there is an innovation trigger, it first goes through this peak of inflated expectations. It comes to a point where everybody is talking about it, people are developing solutions, billions of funding is coming into that topic, and from there, people start to realize that, okay, some of the things that we thought we can do might not be feasible after all. So then we come to the trough of disillusionment. Then slowly, we go through the slope of enlightenment and to the plateau of productivity. So you take any of these innovations, historically, we have seen that this trend was there. You take the internet, I showed you before. Amazon was an outlier. It came into the picture very early, within like 3 years of internet being used in widespread by everyday users. And then later, you can see some of these images you see here, you don't even know them, right? What are those? But the things that you see here on the right-hand side corner of your screen, you are very familiar. Same thing with the cloud. We had some early adopters, and later we went through that, and we came to the productivity portion of our curve. Same with the mobile. Now I can go on and on about talking about every product here in different places of this curve, but that is not my intention. Today what I wanted to highlight is, what can we do as people, as the Google developers, people generally in the tech area, what can we do to contribute to this? And I'm sure you might have guessed by now, when I showed you internet, cloud, and mobile, I'm going to end up somewhere related to generative AI. Well, you guessed right, but before we go there, let me talk about something else. So when you talk about generative AI, the foundation of that is in deep learning. I'm sure you know this. In 2012, there was a key discovery. You can see here on the left-hand side of the corner called AlexNet. So this AlexNet is kind of, it's a paradigm-shifting innovation. People recognize AlexNet as the coming of age of deep learning. Because when AlexNet came into the picture, it was really good compared to the competitors. So you can read about it. If you are closely following this OpenAI drama or the series of incidents over the last 2 weeks or so, there was one name that came up from the OpenAI board of directors, a person by the name of Ilya Sutskever. So this Ilya Sutskever was actually one of the founding people or one of the innovators of AlexNet. So this AlexNet gave rise to a lot of other deep learning architectures. You can see GANs, generative adversarial networks, other CNNs, LSTMs, RNNs. So these are all tools that you can use to actually do something. So when you think about what can you do, there are millions of possibilities. So that's why I said, I will take one case study and show you what can be done. To understand the case study better, I want to highlight the difference between these commonly used phrases. You can see AI. It's the ability of a machine to imitate intelligent human behavior. Machine learning. It's an application of AI that allows a system to automatically learn and do things. And deep learning, it's again a subdivision of machine learning that is dealing with deep neural networks. So these are words that we hear all over the place, but I wanted to clarify it, how everything relates together, because I'll be using these words interchangeably for the rest of the presentation. Right. Now, before going to the case study, I wanted to hear from you. I would appreciate if all of you can go to menti.com or scan the QR code. There are a few questions that we will be going through where you can also participate. So I'll give you a second. So the organizers asked me not to add any open-ended answers to this due to obvious reasons. So therefore, it's going to be like multiple choice or this or that kind of answers. But let's go to Mentimeter and see the questions. All right, so how many people do we have? So a lot of thumbs up coming in. 11 people so far. Come on guys, hurry up. I'm told you there are about 750 people in the audience. 11 is a very small number. Let's go to the question and see how many people are actually voting, because that number might take some time to get updated. So if you can go to the next slide. I want to know from you, this connects back to our case study, which of the following energy efficient technologies have you implemented in your home or workplace? What have you done? Okay, so it's clearly not 11 people, definitely more than that. Cool. Keep them coming. All right, so most of you have LED light bulbs, energy efficient appliances. Not many have programmable thermostats. Well, 80-something people have solar panels. Impressive. I think I should know the audience that you are a tech audience, and having like a DIY, do-it-yourself kind of solar, I'm sure you have done it. We had this power outage yesterday also, so yeah, why not? Okay, so I have an idea about what you have done. Can we go to the next slide in Mentimeter, please? So you need to rank now. What is the biggest barrier to implementing energy efficient practices in your home or workplace? You will see multiple options. Put the most pressing challenge at the top, and you can rank the rest later. Okay? So people are saying lack of knowledge. Really? Lack of knowledge? From you guys? Okay, let's wait without coming to any conclusions. Okay, it's going down. So now I'm kind of relieved. Okay, so looks like an overwhelming majority of you guys are saying that the biggest challenge is the lack of supporting infrastructure. Well, I agree with you. Let's quickly go to the next Mentimeter question as well, and then we'll go to the case study. So when talking about a lack of infrastructure for energy efficiency countermeasures, one thing that we have seen outside of Sri Lanka mainly is that they have what we call a demand response program. Because now you guys said that the lack of infrastructure is your biggest challenge, right? Other people have had the same challenge, and they have implemented something called demand response programs as well to make it more energy efficient. And now more than 170 people are saying they have no clue what this is. Okay, so at the end of today's presentation, I hope at least some of you will have well, not some, all of you, will have some sort of a clue about what demand response is. Right. Can we go back to the slides, please? We'll come back to Mentimeter. So if you logged in, by the way, don't go anywhere. You can keep Mentimeter open on your phone, and we'll come back to that. Right. So my case study is my title of the talk, AI as a tool for energy efficiency. So I'll tell you what the product is, how we have developed it, and how to use the Google Cloud Platform to implement different parts of this tool. So the challenge, you told me this, the challenge is that we don't really have an idea about how much energy we are using within a day. The only thing that we are getting is the electricity bill that you get at the end of the day. Sorry, not the day, the month. So you really lack a bird's eye view of your usage. You don't have device level energy breakdowns. You have no idea how much your refrigerator is consuming. You only know your total electricity bill. You cannot control those appliances. Well, you can, but if you want to, turn the refrigerator on and off, you will have to go there, get close to the wall socket and turn it on and off, right? That's the only option. So that's what you meant by a lack of infrastructure. So this project, this case study that I'm taking, that we have codenamed Oversight, it's an end-to-end solution that can monitor and control appliances in your premises. So the two key things here, monitoring and control. Let's see how we can implement this. To implement this, we need a combination of IoT, AI, and a cloud-based software platform. All three things has to come together. And the high-level architecture of the solution looks like this. More than 80 people had solar panels, so some sort of panels installed from the Mentimeter quiz. So let's assume that you have some sort of a renewable energy source at your home or at your office. We also have smart devices, IoT devices that can monitor and control the appliances. And those devices will gather data and will historically gather these data and keep it in a cloud database. Once we have that information, then we can train a machine learning model to do predictions. I will tell you what these predictions are. And then combining all these things, we have a web-based software application, an interface where the user can interact. Because this has to be used by the everyday user, right? Not just you and me who are capable of understanding how this works. There are people, the everyday public, general public, who has no clue. So that has to be user-friendly. Let me quickly touch upon each and every one of these items, starting from the hardware devices. So the green highlighted ones are the IoT, the smart devices that is powering up Oversight. For the development of IoT devices, we took two approaches. One is to custom design the hardware, and the other one is to use a product available in the market and integrate that into the platform. So what can this do? This can plug itself into a wall socket, and as you can imagine, the refrigerator gets plugged into this. What it allows you to do is to monitor the real-time power consumption, monitor the power consumption in real time, and also, because this is connected to the internet through Wi-Fi, you can turn the appliance on and off. So I believe you can relate to this, how this can work. It's not a very new thing. It has been there for a long time. You might be using them in your homes as well. Then we also have something called the AC controller, which can control air conditioners. That is not simply turning something on and off. It includes setting the temperature, setting the fan speed, those things as well. So these are the smart devices integrated into the platform. Of course, you can add more. Nowadays, we are talking about home security systems. So many options are there. Then the data gathered through these smart devices will go to a cloud-based machine learning engine that is hosting several machine learning models. What does it do? One example of what these machine learning systems can do is when we gather data, we can look at past data and predict the future. For example, we can decide what would be my energy consumption 1 day from today, 1 week from today. So those kind of horizons we can try to predict. And when we do that, the prediction looks something like this. In green, you will see the actual usage. In red, you see the predicted usage. So now, if you have a prediction like this, you can kind of figure out tomorrow what would be my power demand, how much energy will I need for my requirements. Let me give you one example of how that prediction can be used. Now imagine our objective is to minimize the usage from the grid and to maximize the usage from solar panels. Okay? At your home, you have solar panels. The objective is to minimize the usage from the grid and to maximize the usage from the solar panels. That's our objective. How can we do it? Here, you can see during daytime, the solar panels generating energy. It is being used at your home, and also it is being used to charge your battery. Now, the battery is only charged 50%. These are a hypothetical example. Battery is only charged 50%. During night time, the solar is of course not generating anything, but my consumption can be covered using 50% of battery charge. I'm okay. So now I'm not dependent on the grid, right? But what if on a Friday you invited some friends over and you have this, routinely on Fridays you would like to get together with some friends, have some drinks, sing some songs or whatever, right? So during the weekend, your consumption is going to go up. Now you can see in my house, in addition to the appliances that I had before, my consumption has gone up. Now what happened? What happened was, my battery drained off and I had to get power from the national grid. So to prevent this from happening, what we can do is, if we can predict that during weekends my consumption is going to go up, I can predict that and charge my battery up to 100% during daytime. Okay, now you might be thinking, okay, you got the grid power during night, and the only thing you are doing is now taking the grid power during daytime. Same thing that's happening, right? Well, not exactly. That is because during night time in Sri Lanka and in every other country, the demand is very high. So now the Ceylon Electricity Board will have to cater to that demand. But if you reduce the demand during night time and you increase the demand during daytime, which is not very much anyway, then that is a good thing. That's a savings for the utility company, and that savings can come in the form of a financial benefit for you as well. So this is one aspect of a demand response program that we see in other countries. In Sri Lanka, more than 200 of you said you have no clue what that is. So the basic idea is to schedule and shift loads to time periods during the day that is more friendly. For example, you don't need to wash your clothes at 7 p.m., right? You can do it at some other time. It's not a pressing issue unless you have something tomorrow, right? So like that, you can make intelligent decisions to reduce your demand, and as a result of that, you get incentives, right? So now, when you charge during daytime, at night time, you do not rely on the grid. You can get all your requirement covered through the battery storage. So that's one example of how predictions can be used to save energy. Now, when we talk about predictions, it comes under the broader category of predictive analytics. Under that, we have several machine learning models or deep learning architectures that we can use. Each one comes with its own pros and cons, and from that, you can develop your own system. And if you're thinking that to get into a domain like this, I need to develop my hardware, well, that is not necessarily the case. Because there are so many data sets publicly available, you can get them and get started. Right. So I hope now the demand management example is clear. I'll give you a few examples before concluding today, and then we'll go into the GCP implementation. Another use case, energy supply management. So in my previous example, I told you that we'll charge the battery 100% during daytime. But what if there is a thunderstorm and the solar irradiation is very low? What then? If you can predict with a reasonable amount of accuracy that tomorrow it's going to rain, well, which is the job description of the meteorological department, but getting data from that also, can you identify how much of energy can you generate from the solar PV? If you can identify that or predict that, then you can say, okay, I need my battery full. Friday night I have a party. I'm going to charge it today, which is Thursday. Friday is going to rain. That prediction can help you, right? So that is energy supply management. We can also look at the operations and maintenance of this infrastructure. Can be solar panels. If it's a power plant, it can be these huge turbines. Before they fail, can we predict whether it's going to fail? This is now predictive maintenance, right? But you can see all these things are connected together. And then finally, another thing that you can do with deep learning is non-intrusive load monitoring. What is that? When I showed you the hardware, the IoT, the smart plug, you notice that we have to add a smart plug for each appliance, right? So now you might be thinking, okay, how is that scalable? We need so many smart plugs for every lampshade in my house. That's not going to work. Well, that is true. We can identify the high power consuming appliances and plug that smart plug into those, not to your bedside lampshade, because that doesn't make any sense. In addition to that, you can do non-intrusive load monitoring. The idea here is that by looking at the total power signal coming here, by looking at the total power signal coming into your house, can you identify how much of power is my refrigerator using? How can you do it? You look at the power signature, and the refrigerator will have its own power signature, because there's a motor that is starting, and after a while it gets saturated. By looking at the total power signature and training a deep learning model, can you extract the refrigerator part out of it and say that my refrigerator consumed this much of power? That's the idea of non-intrusive load monitoring. It is also called energy disaggregation as well. So whatever technical term you use, I hope you got the idea. So these are some of the things that we can do using deep learning in an energy system. To do that, we need data. And that data can come from system parameters, can come from weather data, can come from our human behavior and natural factors. So these things we feed into the machine learning models, not one, multiple of course, for different use cases, and try to see what can we do. Right. I hope you got the idea of what we are trying to do through oversight. And before I tell you how we can implement this in the cloud, in a cloud platform like GCP, I want to ask from you as Google developers, if you can go back to Mentimeter, would like to get your opinion about what are the different services in the Google Cloud that will enable us to implement something like this. Can we go to the next Mentimeter question? It's the same link, by the way. Same code, same link. These are the responses we got for the previous question. Now, I would like you to tell me which of the following GCP services can be used to implement oversight. You can only select one, by the way. Right, so cloud data flow appears to be the favorite. Well, in fact, we can use all of these services to implement something like oversight. I'm sure you guessed that, because you cannot operate one without the other in most cases, but yes. I'm sorry you did not have an option to select all. That's Mentimeter's fault, not mine. Can we go back to the slide, please? So this is what it can look like. Let me walk you through the individual components, and then we look at the architecture. We need device communication. So the smart devices has to talk to the cloud. It has to happen through communication protocols, like MQTT or HTTP, right? Then we need to do device management. That is where you add devices into the mix, you remove them, you authenticate them. All that happens through device management. Then you gather data. This data comes from various sources, as you saw earlier. That has to be aggregated. The volume and the diversity of data is the challenge. Then we run the machine learning models. We need to be mindful about security and scalability as well. So this is how everything comes together. We have the oversight devices, the smart devices, and all the way on the right, you have the software that the user will interact with. In the middle, we have everything that is doing the work behind the scenes to enable this. starting from the load balancer to balance the traffic coming in from the devices, the IoT platform, the extract, transform, and load pipeline, and the cloud applications. Let me talk to you briefly about each and every one of them. The load balancer, as you know, that is responsible for taking data and distributing that across different servers. In this case, we are distributing it across different MQTT brokers. And these brokers will talk to the device management part for authentication, for registering devices, and for example, if you need to push like a over-the-air update, that has to be done as well. If you lose a device, then the data has to be cleared for security reasons. So all that happens here. Then the data goes to the ETL pipeline. The publisher-subscriber architecture is there so that the devices can publish to a topic and the subscribers can read from that topic. This way we are decoupling. This, I believe you know, it's essential for scalability as well. Then we have the cloud data flow that can clean data, filter data, and transform data because you are getting data from multiple sources. Somebody has to take care of it. That is done by the data flow. And the data then goes to our managed service, the database, BigQuery. So this allows you to seamlessly gather data from multiple locations, run queries, and scalability, all that is taken care of by that. The machine learning models are implemented here. The data studio is used to develop dashboards, reports, charts, and all that. Then the Kubernetes engine for containerization and scalability and virtualization. And finally, what the user gets is the portal. So that's a high-level overview of how oversight can be implemented in GCP. There are, of course, minor details. Didn't go to that, but I hope you got the idea. Right. So that's my case study of how we can use machine learning to save energy or to make energy more efficient. But now let me continue the brief history of innovation and conclude by giving you the call to action. So we stopped here. We stopped by looking at deep learning architectures. In 2017, something interesting happened. That is the development of the transformer. This is not the transformer of the electricity grid. I hope you know the difference. Again, we have Google to thank this. Some of the researchers at Google came up with the initial core structure of a transformer. And that led to the generative AI revolution. So in my triggers to mass market innovation, you can see in 2017, the transformer happened. And the mass market innovation of that, we now today identify as ChatGPT. What is interesting about ChatGPT is, compared to any other innovation, ChatGPT is in a league of its own. We spent only 2 months to gather 100 million users, compared to Apple, which took 14 years to get 100 million users for their products. You can see why I call it a league of its own. It's unprecedented. Things that took months and years for us, now it only takes a few seconds. Yesterday, when I was preparing the slides, I asked DALL-E, which is an OpenAI service, to generate an image that shows a human civilization empowered by AI and digital transformation. I got this image in less than a minute. So for me, who's not a very artistic person, if I draw, it'll look terrible. This took only less than 1 minute. So we are living in a very interesting time right now. And we need to pause a bit and appreciate that. Because if you don't do that, most of the opportunities will just go past you. And when speaking of opportunities, ChatGPT is like the biggest driver. Out of about 15 billion funding that came into generative AI, ChatGPT got about 10 billion of it. So it's a major player. But there are other players as well, as you know. Right? Google has its own. Gemini was released recently. So a lot of things happening in this area. So you guys need to be equipped to make use of it. And when I say make use of it, the important thing to understand is that innovation is not only happening in the application space. A lot of things are going on right now. If you look at the quarterly earnings of NVIDIA, in 2024, these are predictions. You can see the boom, right? You can see the trend. Why? Even OpenAI is using NVIDIA chipsets like the H100. I should have actually added a question on Mentimeter for that and make you guess the cost of an H100. That's a GPU, by the way, that you can use to train generative AI models that cost somewhere between $30,000 to $40,000, right? So NVIDIA is making use by not taking part in the application space, but by taking part in the enabler, by playing the role of an enabler for generative AI. My point to you is, when you look at opportunities in this entire stack. Because typically what we do is, we look at product, design, and application. That's pretty much it, right? That's what we do in most cases. But that should not be the case. NVIDIA is playing in the middle. Maybe you don't want to go to physics. From bottom to the top, you can see we talk about gates, the microarchitectures, the processor pipeline, and the instruction set like x86, and the machine code assembly, programming languages, that is what you're familiar with, your C, C++, Python, Java, whatever. And then you build applications on top of it, right? If you are going after generative AI applications, you'll pretty much stay at the top. But there are opportunities at the middle as well. That is what NVIDIA has done, and that is what we can look. Imagine that you can have a custom LLM on your phone. That is not possible right now, because these are very heavy, right? If you can have a lightweight LLM on your phone, your data stays with you, doesn't go anywhere. You can have it as a personal assistant. That is not possible right now, because these models are huge. But definitely the day that is possible will not be too far. And at that point, there will be a lot of other possibilities, and the people who do that will be, of course, billionaires. So my call to action for you is that opportunities are everywhere. It is never a lack of opportunities. The main challenge is the lack of talent that we have, the people who can develop these things. And that is where you guys come in. So my call to action for you is, there are so many things to explore. Look at that. If you are a university student, look at what can be possible. Once you graduate, don't stop learning. Keep on learning, always, and then opportunities you will see. So with that, a huge shout out to the Syntax Genie team who's somewhere here, who made oversight possible and without which I will not be here talking to you. And for GDG, thank you for having me. Thanks.
Thank you, Subodha, for that wonderfully info-packed, eye-opening session. So we would like to have you again over on the stage to present you with a small token of appreciation. To present Subodha with his token of appreciation, we will also have Mr. Suresh, who is also a GDG Sri Lanka organizer.